In this video, we're going to go over the simplified gas laws and Boyle's law. So gas laws involve the mathematical relationships among four variables that describe the macroscopic properties of a gas: pressure, volume, temperature, and moles. The simple gas laws are the relationship between two of these variables that reliably predict how a change in one variable will affect the other variable when the other two variables are held constant. Boyle's law is pressure and volume are inversely proportional. As volume increases, pressure increases when moles and temperature are constant. Charles' law states that volume and temperature are directly proportional. As temperature increases, volume increases when moles and pressure are constant. Gay-Lussac's law says that pressure and temperature are directly proportional. As temperature increases, pressure increases when moles and volume are constant. This is a graph of the simplified gas laws. You can see that with volume on the x-axis and pressure on the y-axis, it's not a linear relationship for Boyle's law. But if you have 1 over volume, so the inverse of volume, you get a linear relationship. So we know that pressure is inversely related to volume. We also see that as volume increases, temperature also increases for Charles' law, according to the graph, and then pressure is directly proportional to temperature. As pressure increases, so does temperature. So Boyle's law, pressure and volume are inversely related when moles and temperature are constant. The pressure inside the barrel, when you decrease volume, increases because the same number of gas molecules are present and they collide with a much smaller wall area in the barrel. So you have the same amount of molecules, but they have less area to move around. So they're hitting the walls a lot more. The equation for Boyle's law is the initial pressure times the initial volume is equal to the final pressure times the final volume. Boyle's law is really important in scuba diving. When diving below the surface of the sea, a diver experiences an increase in pressure and therefore a decrease in volume in the air of their lungs. As the diver ascends back to the surface, where the pressure is lower, the volume of the air in the diver's lung increases, and this is why divers are instructed not to hold their breath while they're underwater, especially when they ascend back up to the surface. So pressure, volume, and breathing. Gases spontaneously flow from regions of higher pressure to regions of lower pressure. So when you inhale, your diaphragm moves downward and the lungs expand. So the volume of your lungs increase and pressure decreases. And since the atmospheric pressure is slightly higher than the pressure in the expanded lungs, outside air enters your lungs. When you exhale, your diaphragm moves upwards, decreasing the volume of your lungs, and therefore increasing pressure. And the pressure is greater than the atmospheric pressure. This increased pressure in the lungs causes unused air and carbon dioxide to be expelled from the lungs. So to practice, a helium balloon with a volume of 1.1 liters and a pressure of 0.91 atmospheres expands to 3.1 liters after being taken into the mountains. What is the new pressure, assuming no change in temperature and no gas escaped? So we're going to use Boyle's law equation for this, which is the initial pressure and the initial volume is equal to the final pressure and final volume. I'm going to write out my variables and say to figure out what I'm looking for. So the initial pressure is 0.91 atmosphere. The initial volume is 1.1 liters. The final volume is 3.1 liters, and we want to know the new pressure. So I'm just going to plug that into my equation. So 0.91 atmospheres times 1.1 liters is equal to the final pressure times 3.1 liters. I'm going to divide each side by 3.1 liters. Cancel that out. And the final pressure is 0.32 atmospheres. We increased our volume, and therefore our pressure should have decreased. It went from 0.91 to 0.32, and it did, so that number makes sense. So in summary, Boyle's law describes the inverse relationship between the pressure and volume of a gas when the amount of gas and the temperature are constant. Char's law states that volume and temperature are directly proportional. Gay-Lussac's law states that pressure and temperature are directly proportional. Boyle's law, expressed in terms of initial and final conditions, is the initial pressure times the initial volume is equal to the final pressure times the final volume. Breathing is an example of a pressure-volume relationship.